Now that we know how to calculate a gradient, we're going to learn some properties of gradients. So first off are some kind of like basic calculus ones. So the gradient is just a container for partial derivatives. So everything that you think is true about derivatives is going to be true about the gradient. So there's going to be linearity. For two functions, f and g. There's going to be a product rule. So the gradient of f times g is going to be, I'll do it, g times the gradient of f plus f times the gradient of g. There's also a quotient rule. So the gradient of f over g is g times the gradient of f minus f times the gradient of g all over g squared. And this one might look a little bit confusing. We had kind of like a vector over a number in some example problems and exam problems in the past. And having one thing in the denominator of a vector kind of confused people. But remember, you can just pass that denominator through every component of a vector. So I don't want that to trip you all up. And then there's a power rule. The gradient of f to the n is just n times f to the n minus 1 grad f. That one's really like just taking advantage of a chain rule in every component of the gradient. So those are just some basic computational facts that you can use when you have to compute gradients. And then there's also a geometric fact that I want us to remember about the gradient. So the gradient is going to point in the direction where, so we're just going to say that's a gradient grad f. Here, actually, I'm going to undo this whole thing so that I'm really consistent about what we're talking about. So the gradient grad f points in the xy direction in which f of xy increases most quickly. And if you think about f being a surface, z equal to f of xy looks like a 3D surface. That's going to be the direction where that surface has the steepest ascent. Steepest ascent. Sorry, I should have enunciated that. Ascent meaning you're going upwards. And this is all evaluated at a point. Oops. This is true at every point we calculate grad f. And then once you sort of calculate all this at a point, you can also say that the magnitude is going to tell us how quickly F is changing in that direction. And so, do I have time to do a quick example on that? You know what? We'll stop here. We'll do an example and a picture in the next one because all this can be a little bit unclear until we have